This is an additional video that dives a bit further into the concepts of ROS actions. While these concepts are certainly useful to know about, they are not necessary to complete the assignments. Alright then, in the last video, we added our action file to cmake_lists.txt, and also we saw that we can use the genaction.py script to generate action messages for us. In fact, the genaction script generated 7 message files, but we only specified 3 message fields, one for goal, one for the result, and one for the feedback in our action file. That would mean we expected only 3 messages, or the 3 message files to be generated, but we have 7. So let's try to understand why the additional messages are needed. The first thing we can observe is that the first 4 messages are having the word action in their names. These are messages that are actually used by the actionlib ROS package for internal handling of our action goals. What we as users will use, as you will find out in the next video, are these 3 messages that correspond to the goal, result, and feedback, and these fields of our action definition. Notice that they do not have the word action in their names. And if we use the ROS message show command for these 3 topics, we can see that their contents correspond to what we have defined in the previous video as contents of our action file. Now, let's focus back on the message files that did have the word action in them, particularly the counterwithDelayAction.msg, which is an aggregation of the 3 other messages with the word action in them, and this message type is also the message type we will use in the code illustration as the type of our action server and action client. For example, let's take a look at this code snippet of an action client. We learned in the previous video that the action client sends a goal to an action server where the goal will be processed. The first thing we can notice here is that the action client is of type counterwithDelayAction, which was highlighted in the previous slide. In other words, this is the action type of our action client. We also notice that we use the message type counterwithDelayGoal that does not have the word action in it. That is because the action client code is something that we as users develop to be able to leverage the facilities of the actionlib ROS package. And when we send the goal from our client, this goal is registered by the action server and the actionlib ROS package. And the actionlib package requires additional information along with the action messages that we as users pass to it. And that additional information is actually the content of the counterwithDelayAction message type. Well, it's quite long that 2 slides are needed for this, but let's see what these extra things mean. Notice here that the action goal and the action result have the text action underscore prefixed to the goal and result fields of the messages on the user side. This indicates that the information is used by the actionlib package. Now, once the goal is registered by the action server, the request is first given a timestamp and header information by actionlib, indicating when and which action client requested this goal. Then, the actionlib package also assigns a unique goal identifier to this goal, also with a timestamp. And finally, we have the goal message that we sent from our action client. Now, the same goes with the action result. We have the timestamp and header information for the result message that will eventually become available after the goal processing completes. And in the actionlib package, there is actually a state machine that is started to process the goal request we send, and this state machine can lead to the requested goal being in different states. And that is what is the purpose of the status message of the action result. Then we have the feedback action underscore feedback message. Here too, we have the timestamp and header information first. And because This is a feedback message to the user as to what is going on the action server. It also has the goal status field that corresponds to the state that the action goal processing state machine is in. And lastly, the content of the user side feedback message. And a quick sneak peek into the action server code snippet, where we see the action server initialization here and the goal callback here. And here too, we say that the action server type has the counter with delay action type. We will understand these code snippets in more detail in the code illustration in the following video. But what is important here is to understand that the action server publishes 4 topics. While the names of these topics are quite intuitive, let's understand 2 important things. First, the feedback topic is published by the action server and has the action feedback message type. And second, the action server subscribes to the cancel topic, and this is of the goal ID type. So, any node that wants to cancel a specific goal can publish the specific goal ID on the cancel topic, and the server will take care of cancelling the goal processing for that goal. And now, a few important things to remember. What we have learned is this simple action server and action client, which is just an instance of the generic action server or client implementation in the ActionLib package. The simple action server enables the non-blocking execution of one action goal at a time. If a new goal is sent to an action server that's already busy with processing a goal, then the currently active goal will be preempted. But this is not a hard limitation. As users, we can always have our own action server implementation that can process multiple goals. All right then, see you soon for the code illustration.